Hello everyone, welcome back to our channel. Today we are back with one more linked list problem that is there in blind 75 SD sheet. So the name of the problem is merge k sorted arrays. Okay, so what we have to do in this question, let's see the problem statement first. We have been given k different arrays or list, we can say, which are sorted individually in ascending order. We need to merge all the given arrays or lists such that the output array list should be sorted in ascending order. Okay, so let's see the explanation part. Like we are given k sorted arrays and we need to merge them into a single sorted array. Okay, so basically input is basically integer t. First of all, where we have to see the how we are tackling the input. So integer t, that is the number of test cases. For each test case, an integer k, that is for number of sorted arrays. For each array, that is an integer n, that is the number of elements in the array, followed by an integer representing the sorted array. Okay, so the output will be a single sorted array combining all the elements from the given k sorted arrays. Okay, now let's have a look on the constraint. Basically, test case we can't take more than 5. Basically, this can depend on code editor. Basically, we will be doing on Code Studio. So next thing is number of arrays we can take not more than 5. Okay, and apart from that, number of elements should be not more than 20. Okay, so data values can range between -10 to the power 5 to 10 to the power 5. So let's see the example. Like we have input 1, 2, 3, 3, 5. So basically this was the 1 is basically the test case, and 2 is basically the number of arrays, and 3 is the number of elements in array 1, that is 3, 5, 9, and number of elements in array 2, that is 4, that is 1, 2, 3, 8. So the sample output for this will be 1, 2, 3, 3, 5, 8, 9. It will be getting arranged in ascending order. Okay, so what will happen is basically this was the problem. Like we can see 3, 5, 9 and 1, 2, 3, 8. If we combine both and arrange in ascending order, we will get this as output. Okay, similarly we can see this. The first array was 3, 5, 9 and second array was 1, 2, 3, 8. After merging the both, we are getting this. So what should be the brute force approach to solve this question? It's quite simple. Like idea is to combine all the arrays into one large array. Basically we can use a sorting algorithm like sort function in Python or sort in C++ to sort the merged array. Okay, so steps are basically creating an empty result array and traversing through each array and inserting its element into the result array, right? Then sorting the result array finally. So after that we need to return the sorted result. This thing looks very easy and simple, yes, but what is the problem in this thing is basically it will consume a lot of time. Basically the time complexity will be O of n log n, since sorting the merged array requires O of n log n. Okay, so wherein n is the total number of element across the array, and space complexity is also O of n because we are taking extra array for the merged result. Okay, so the drawback for this approach is quite clear. Like sorting everything together may waste time since we already have sorted arrays. So what we can do, basically we can optimize the solution. So let's see how we will do that. Basically optimize approach is basically we will do with the help of Min-Heap, or we can say priority queue. So idea is basically we will use a Min-Heap to efficiently merge the sorted arrays, and since all the arrays are sorted, we will pick the smallest element among them, and basically we will insert it into the result array. Okay, so the steps I am going to discuss with you all. First of all, the foremost thing, like we are using Min-Heap, so we need to create a Min-Heap first. After that we need to insert the first element of each array into the heap along with its array index and element index. Okay, after that, while the heap is not empty, like it is the condition, so basically while the heap is not empty, we need to extract the smallest element from the heap. Okay, and after that we need to add this element to the result array. Basically we are adding the element to the result array, simple. After that we need to insert the next element from the same array into the heap. Okay, if available. Basically it's not a compulsion. Okay, now I will do a try run for you like I have already did, so it will be more easier for you all to understand. Basically the input was 359 and 1238. These were the two arrays we have to merge in, and finally we have to return the final result in ascending order. So step 1 is inserting the first elements into the heap, that is 1 comma 3. Okay, so first element of both the arrays, like first element is 1 and here first element is 3, we have inserted. Then extract 1. After that we need to insert 2, result will be 1. Okay, we have taken 1. Then after that we need to extract 2, that is insert 3, so result will be 1 comma 2. Basically we used min-heap because so extracting data and after that pushing it into the new array. Okay, so extract 3, insert 3, result will be 1 2 3. Again we have another 3, so we are inserting like this, and similarly by doing the same operation multiple times we reach at the final state and the result will be 1 2 3 3 5 8 9. That is the final result we need to return. So basically the time complexity for this approach will be like O of n log k, and each insertion and extraction in the heap takes O of log k. So there are n elements. Okay, space complexity will be also O of k. The heap will store at most k elements at a time. So this is far better approach as compared to brute force. Let's see the code in the code studio. Basically this is the function merge sorted arrays and vector int result for the final merged sorted array, and then we have to create min-heap to track the smallest elements from each array, that is priority queue, pair int. Similarly this is the creation of min-heap. Then other is inserting the first element of each array into the heap. Okay, so after that we need to take the value array index and element index. Step 2 is basically extracting the smallest element and adding the next element from the same array. Okay, so in min-heap.empty, this is the function. Okay, so here is a while loop we need to do under this, and extracting the smallest element. Basically after that popping out the which is not smallest. Okay, so next one is basically value of the smallest index value is equals to current dot first. Okay, and after that we have to see int array index is equals to current second dot first. Okay, which array the element came from, we have to decide. Then afterwards we need to take care of the element index also. So for this we are taking index of this element in its array, we have to store it in this variable. After that we need to push the result in the value, that is extracted element, to the result array, and finally insert the next element from the same array if available. So this is the syntax for this. Basically if you don't know the syntax, so it will be quite complex code for you all, so it's better, no need to worry about this. Basically this thing will come with practice, nothing extraordinary is there, just we have implemented the priority queue, or we can say the min-heap. After that finally we have to return the result, we need to return the merge sorted array result. So this was the explanation part and solution. If you guys like the explanation and understood the solution, please hit the like button and also share it with the other students as well. Thank you.